Hi, hello, hello. Am I audible? Am I visible? It's a mic test 1, 2, 3. It's a video audio test 1, 2, 3. How is everybody doing? What's up? JEE Mains 2025. After so much of hue and cry, after so much of the hype, how difficult the paper shall be, after so many YouTube videos all making anxiety double, huh? Here we are with the first shift. Everybody was waiting for it, how it is going to be tough, easy, moderate, but it turned out how it always was, right? It was not very difficult. It was not very simple as well. It was a mix of everything. If you've practiced well, you should score good. You should be able to score yourself easily. More than 20 questions can be right for sure. Right? So before I proceed any further, is there anybody along with us? Is there anybody who is still in the festival zone of JEE Mains who should watch this session? If you're a JEE Main, who's JEE Main aspirant whose paper is just round the corner, this session is for you. If you're NEET aspirant, this session is of course for you because it will give you an insight into NTA's mind. So all the JEE Mains and NEET level is kind of at par right now, at par. It is absolutely very similar. So all the NEET aspirants are supposed to look at this session as well. This session will contain everything about the full chemistry portion. So even if nobody is joining in, my intention is to be a part of this celebration, JEE Mains, to be not a viewer, spectator ion. You remember what are spectator ions? Ions which are not responsible at all for any kind of changes which are happening. So I did not want to be a spectator ion. So I've come up with a full chemistry JEE Mains 2025 shift 1, 22nd Jan. And there are questions waiting for us. Let's get started. Okay. It will be fun for me as well. Let's see the first question. Compare boiling point of the given solutions. Now, before you do that, let me just very quickly check whether, am I audible as well? Because I am not getting any confirmation from anybody. Okay, I think, I don't know if I'm audible or visible. Okay, anybody there? Anybody who can give me a... Okay. Okay, I think all is set from my end. Let's get started. Okay. First question, compare boiling point of the given solutions. So the session starts from here. 10 to the power minus 4 NaCl. So I here is 2, I here is 2, I here is 2, I here is 1, right? And then the concentrations 10 to the power minus 2, 10 to the power minus 3, 10 to the power minus 4, say all of them are in molal. Okay, this is the molal concentration. So you know I Kb into M is your delta Tb, boiling points you were comparing. So higher the I into M, that means this is the highest, right? The third one is the highest. So answer can either be second or fourth. It cannot be third or first. So out of this, first is this, then is this. So third and then second. Third and then second. So answer has to be option 2 for this question. Okay. All right. Next one. Next question. In NiCl4 minus, what is the charge on metal and shape of the complex respectively? Let's find that out, okay? If we have NiCl4, Cl minus is a weak ligand. This we know. Everybody knows this. So what will happen as a result? Nickel is in what oxidation state? -4 is equal to -2. So X comes out to be +2. So it cannot be third or fourth. 50-50 has been done. Okay. Now, Ni2 plus is there. So that means the configuration, chodo T, V, car, mango, fico, ni, 28. So it is 4s2, 3d8. 2 plus 2 electron goes from 4s, 3d8. And because it is weak ligand, no pairing will happen. 1, 2, 3, 4, 5, 6, 7, 8. And we have empty 4s, empty 4p, empty 4d. 3d is all occupied. So sp3 gets occupied in order to form tetrahedral geometry. So please see A becomes the answer for this question. All right, super, great. Let's see now the next question, the correct decreasing order of electronegativity. So when we talk about electronegativity, we know it's FON, F-O-N. So F should be async. F should be async. Answer cannot be C or D. Okay, second and fourth cannot be your answers, 1 or 3. Fluorine, after that chlorine, and then you know what should have happened. Fluorine, chlorine, bromine, iodine. Yeah, so what should be the answer? It should be in this perfect sequence. Fluorine and then chlorine and then bromine and then least is iodine. So it's very direct question if you see. C becomes the answer. The third one becomes the answer to this question. Which of the following lanthanide ion has 7 electrons in outermost shell? Okay, so for this I taught you a trick. If you have seen the trick, then this will be very easy. So if you're joining new to my channel, I would first of all let you know that this is a channel dedicated to chemistry. The work that you see on the channel is just motivation driven. If you see, I've put a lot of my ideology into the videos, into the shorts, into anything that I put on the channel. That's something that I really want, that chemistry should be connected to everyday life. And that's what you would probably see. And here is the trick that I've taught in one of my shorts as well. SSP, SPS, DPS, DPS, FDPS, FDPS. So you can just club them into group. This can be one group, this can be another group, this can be one group, this can be one group, this can be one group, and this can be one group. So if you see, there can be 10 electrons here, 6, 2 and 2, 2, 6 and 2, 10 here, 18 here, 6, 10 and 2, 18 here, and then you can see that 14 is being added to same DPS. So if it was 18 plus 10, that means 28. So it was 14. So 32 here and 32 here. If you see, we want to come to 63. Europium is 63. So 10, 20, 30, 40, 50, 60. 60 minus 4 is 54. So till here we are reaching 54. 55, 56, 57, 58, 59, 60, 61. Okay, till here we are reaching 56, right? We are reaching 4, we have to subtract, so we are reaching 56, 57, 58, 59, 60, 61, 62, 63. So we are reaching here at 63. So which is europium? And you have various options basically. If you see, you would have had EU3 plus, EU4 plus, gadonium GD3 plus and GD I think 2 plus, something like that was there. So here we can see that if we are talking about gadonium, which has 1 electron more, which goes in 4d1, okay, so that 4f maintains half-filled electronic configuration. So 2 electrons from here and 1 from here, if you remove, you will get how many electrons have been removed? 3 electrons. So GD3 plus is going to be the right answer. So the trick really helps you. The trick really helps you. SSP, SPS, DPS, DPS, FDPS, FDPS, it has its own limitations, but those are the limitations that are very acceptable. Why are they acceptable? Here is the reason, because if there is a possibility of having a half-filled F subshell, why not? Or a fully filled D subshell, why not? That brings in more symmetry, that brings in more exchange energy. Okay, next. If you see this question, a perfect question, and what is asked is molecular weight. So sequence question, you know that we are doing reduction of nitrobenzene to get aniline. Then you're adding sodium nitrite in the presence of hydrochloric acid. What will happen? You will end up getting disonium. You will end up getting benzene disonium chloride, BDC. Right? Still on. Oh, nice. We were planning to do it together. And if you add CuCl to it, you get chlorobenzene, and then you get this Fittig reaction, which is giving you C12H10, and you can find out the molecular weight. Right? It was nice one, simple one, but interesting one. Next one is all about maximum size. We know negative charges are always going to have maximum size. That means look for the negative. And the negative, the higher the negative charge, that will be the answer. But here we have just one, so third becomes the answer, right? But this is to be kept in mind that we are talking about positive charges, Mg, which might not be of the second period, yet our answer will be determined by the second period combined with, if you're talking about the second period, we have to combine it with the knowledge of the ions that we have. Please check. So if we look at the F minus size, do you know what is the size of F minus ion? Have you ever tried to figure out? It is 133 picometer. And have you ever tried what is the radius of Mg2 plus? Because it is positive even though it is lying in the third period, if you see. So if you see, we have Hahi, Li, Bieber, Knopf, Nina, Meg, Ulci, per circle. So if you see, we have F minus and we have magnesiums and aluminiums, yet they are going to have lesser size. If you see, aluminium 3 plus has very less size, 57 picometer approximately, and this is some 60s. If you see, I think, yeah, it is 79 picometer. Like, right, if you're saying this, you're absolutely right. You can see that what we have is always a negative species, even if it is not going to be of the same period, yet has this higher size because of the charge. Rushabh, my friend, is saying nostalgia ho gaya pichle saal ka. Bhumika ma'am, Ashish sir, Abhishek sir in one frame. Absolutely. So Rushabh, nostalgia, I did not want to be out of this celebration like I'm saying. JEE Mains is a celebration. Being out of the celebrations is not justified. No, it is not for you. It is for me. I'm not doing it for you. I'm doing it for me. Okay, yeah, so you gave the right order as well. Now we move on. How many compounds have linear shape? So SO2, we know that is going to be bent shape. 6 by 2 is 3, so you get bent shape. Beryllium chloride, we have not been mentioned what state it is. You can understand that here they can be bridge bonding also. And if they can be bridge bonding here, then the hybridization can become sp2 and sp3, both depending on what the condition is. But here we'll go with the simple rule. So yes, BeCl2 will draw linear. N3 minus is again linear. I3 minus is again, you can think of it like this, I2I with the minus. So iodine 7 plus 2 monoatomic species plus 1 by 2. 10 by 2 is 5, but 3 iodines are there. So they're going to occupy the axial positions, leaving 3 lone pair here, but it is going to be linear. NO2 plus, so 5 minus 1 by 2, 4 by 2 is 2. So NO2 plus is also linear, right? So this is linear, this is linear, this is linear, this is linear, this is NO2. If this was plus, it is never linear. Even if it is one free radical present, then also it is not linear, right? So of course 1, 2, 3 and 4, if these were the options. So this is a memory based question. Some of you told on Discord, some of you let me know, and some I got to know from the other channels also. So I can't take the responsibility that the questions are correct, but all I can say is it gives you a mirror. It gives you a peek into NTA's syllabus. So it is henceforth important for us to actually figure out what was the complexity level, what is this the always kind of a pattern or some extra edgy things are there, so we can figure it out through the previous year paper question solving, right? Next question, carbon dioxide gas plus carbon gives you carbon monoxide. Now this is class 8th reaction coming in front of you. If initial pressure of carbon dioxide is 0.6 and after equilibrium is established, it is 0.8, then Kp. So you know how to find out Kp, right? What we can simply do is carbon dioxide plus carbon giving us 2 carbon monoxide, right? If it was 0.6, then after some time, let's say pressure decreased is X. This is solid, so I'm not worrying about it. I'm just worrying about the gases, and this formed as 2x. And this total pressure is given to us as 0.8. So x is going to be 0.2, right? This means 0.6 plus x is equal to 0.8. So x is equal to 0.2. So Kp is going to be equal to the concentration of CO or the partial pressure of CO to the power 2 divided by the partial pressure of the carbon dioxide. So this is 2x. So 2 into 0.2 is 0.4 into 2, 0.4 to the power 2, and this is going to be minus, so 0.4. So one of the 0.4s is Tata bye-bye. You end up getting 0.4 as your answer. Correct? Okay, next. In Carius method, now this is again one of the simplest questions, and all that you required was the molecular mass of AgCl. So 108 plus 35.5. This you should know. 8, 9, 10, 11, 12, 13, 3, 4, 143.5. I am a chemist person. I am not mathematician. And because I'm not mathematician, I have all the legitimate right. I have all the rights in the world to do approximation. So yes, I'll do approximation and consider it 144. So can I say 1 mole of AgCl produces 35.5 gram of chlorine? Right? What has happened here? 180 gram of the product has 144. So in Carius method, estimation of the chlorine or a compound of 180 gram produces 144 gram of AgCl. So this much some product it has given 144 gram of AgCl, which is equal to the molecular mass. So this would have had 35.5 gram of chlorine. So 35.5 divided by, now what's the percentage? Divided by the total product which is present in 200. Let's consider this also as 36 to solve it. So this becomes 2, this becomes 1, 18 into 2 is 36, 0, 0 cancelled out. So approximately 20% becomes the answer. Okay, you can do it if you want. If you want to do exact calculation, you are free to do it. But like I said, the examiner would keep the error in mind, considering that this is not to test your math, but to test your chemistry, right? Hence, we can go with approximately 20% as our answer. Okay, next. This we have already done. We saw that how GD3 plus, SSP, SPS, GPS, GPS, FDPS, FDPS. Next. Number of stereoisomers I was teaching my students yesterday. I don't know if any one of you whom I taught yesterday, the same question we have done yesterday while discussing stereoisomers. And there we talked about the same example that one chiral center was there because this carbon is attached to 4 different groups, and one restricted rotation with different side groups. Hence, this will show cis and trans isomerism. Like I told you, I do not like using formulas here. So you can see with cis there is a possibility of D, with cis there is a possibility of L, with trans there is a possibility of D, with trans there is a possibility of L. So 4 different isomers are possible, 2 because of this, 2 because of this, combination these 4, right? Okay, next one. Statement 1, we have this particular molecule. This will show nucleophilic substitution by SN1. Whenever SN1 comes, the first thing is make carbocation. Check whether it is stable. And yes, that's a very stable carbocation because there is conjugation. So SN1 will happen. But in the second one, it is saying this will show nucleophilic substitution via SN2 easily. Now, we have to check the kind of the alkyl halide that is there should not be bulky, and it's a huge bulky group. So how will the nucleophile enter from the opposite side? It can't. So no SN2. So second statement is a false. It will never undergo SN2 easily. So this one is true, the other one is false. Hence, we will go with third answer. Okay, next one. An electron of helium plus is present in third excited state. Find its de Broglie wavelength. So all that you need to remember is when an electron of helium plus is present in the third excited state. So it's basically the circumference which will be equal to, if this is, let's say, one wavelength. So you will see that one wavelength into n will give you the entire circumference. So n into lambda is your circumference, and circumference is 2 pi r. Now, if you have been following my channel, you would have seen I am giving you so many tricks. I would really be indebted if you spread across the chemistry vibe, the chemistry energy, the chemistry resonance, the chemistry subject, the chemistry feeling across your friends. If you can do that, it will motivate me to work harder on this channel, which I am intending to put all my philosophy to. Hey Soumya, so good to see you. Hey, Soumya, you remember this is the exact question we did yesterday. I mean, the last isomerism topic that we did. If you remember, stereoisomers, when we were learning, we just did this particular example. Same question came in JEE mains. Okay, so yeah, here we come to the answer by saying that circumference is equal to n lambda. Now, n is going to be what? It is the third excited state. So n is going to be equal to 4. So this is n, 2 pi r. Now r, if you are following my channel, you would know that we talk about run-tos. Please make sure this is also a session for you to get some tidbits of different tricks. So please, first trick, everybody whose JEE mains is awaited, or if you're a NEET aspirant, you should know these 3 formulas. Izzat do na do. Izzat do na do. Run-tos. Vazan. Okay, so the sound of Z is for Z, atomic number. The sound of N is for the shell number. And if there is a 2 coming, that's for the square. So you should never get confused. Please remember, energy is equal to Izzat do na do. So E is coming first, Izz, then Z, do, that means square, na, that means N, do, again square. Run-tos. So R is equal to R naught, run-tos, N square by Z. Vazan, V is equal to V naught, Z by N. There's no do or 2 here. The 2 and do is for the 2 as a power. So yeah, here you have the 3 formulas. Here you have R. So just put R naught N square by Z, run-tos. Okay, now n square we already know 4 square. Z we already know is 2. R naught. Do we know R naught? Yes, we know. In decimeter, if you have, in angstrom, if you have your answers, angstrom, if you have your units, so you use 0.529 n square by z. So that's what we are substituting. 2 pi r is equal to nz, and for r, we are using r naught. That means 0.529 n square, that means 4 square, by z, helium is 2. So you get here 4 square is equal to 16, but we get an 8 here, right? So we can solve this now. You can just solve this and you will see that what do you get? Let's get rid of the 2's. Let's see the calculations. Let's get rid of these 2's. Let's get rid of one of the 4's. So lambda is equal to, do you see 0.529? Let's make it 0.5 into 4 into, let's write pi as 3.14. So 5 4s are 20, but 1 decimal. So 2 into 3.14 makes it 4, 3 into 2, 6, 6.28, somewhere around 6 as your answer. So your answer to this question will be option A. Okay. Next, identify the incorrect statement. So I'm not very sure whether this question is correct, but let's go behind the concepts of the question. You guys can let me know in the chat how this question was. Was it in the same format as it is? And feel free to comment, please. This is your channel. Okay. So let it be a vent for you. Okay. Now, melting point of cis-butene is lesser than trans-butene. So, melting point always of trans is more, because when it comes to the melting point, it is all about how the packing is, more the packing efficiency. More closely it will be sitting with each other, more energy will be required to break the lattice. Hence, melting point will be high if packing is efficient, if packing efficiency is high. So, which is there in trans. So, trans should have higher melting point. That's what is written. Melting point of cis-butene is lesser than trans-butene. Okay. 2-methyl-2-butene has 2 GI. Now, let's see. Let's make 2-methyl-butene. This is your 2-methyl-butene. Now you can see that you have a restricted rotation, but you have the same group on one side, making this not fulfilling the condition of GI that you need to have a restricted rotation and different groups on either side of the restricted bond. So here, this is, of course, if you see, will have no GI. So B becomes the answer to this question. Dipole moment of cis is greater than trans. So any of my students who I'm currently teaching, if you're watching it, you know that we have done this question as well while studying the geometrical isomerism, while studying stereoisomers. Dipole moment of cis is always greater than trans. This is true. In trans isomer, identical groups are opposite sides. That's also true. B becomes the right answer. Okay. This we are done. And with this, most of the questions that I've got are over. So this is just an experimentation to know that are you still there? Are you following? Are you even following what the content that I'm putting? Is it resonating with you? So it's just a way of, meeting you. That's it. So if you're liking this session, please let me know in the comments and stay in the best of your spirits. If your paper is awaited, I wish you all the best. All the best. Do your best and do not worry. Okay. The life is about exposure. You will get exposure no matter in what way, right? So with this, if everything goes well, we'll see each other once again. This is me, Nitika, signing off. This was from my side, Rasayan Pryogshala. Bye-bye. All the best. Take care.